Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam, there is a point load 32 kN. It acts at a distance of 3 meter from the left support. Also, there is uniformly distributed load 24 kN per meter. It is acting in the entire span. The length of the beam is given as 6 meter. Now let us find the degree of static indeterminacy. In this beam, the number of unknown reactions and moments are 3. The available equilibrium equations are 2. The degree of static indeterminacy will be 3 minus 2. We will get 1. Let us take Rb as the redundant. To find Rb, we are going to use strain energy method. We have to use this formula. Strain energy U is equal to 1 upon 2 EI integration of m square dx. To use this formula, we have to make sections. In this beam, there are two different parts, BC and CA. So we have to make two sections, one in BC and one in CA. You can see that I have made two sections, one in BC and one in CA. I have made both of the sections at a distance of x from the point B. Since there are two sections, we have to split this formula into two parts. For the first part, the limit is 0 to 3, and for the second part, the limit is 3 to 6. Now we are going to find the moments m1 and m2. We are going to find the moments from the point B. In this case, we have to follow left hand side rule. Clockwise will be negative and anti-clockwise will be positive. Let us find m1. Up to this section, we have RB and the uniformly distributed load 24. RB is acting in the anti-clockwise direction so that it will be positive and the distance is x. The uniformly distributed load 24 is acting in the clockwise direction so that it will be negative and the distance is x. We know that with the UDL we have to multiply the distance and then the distance by 2. 24 upon 2 it will be 12, x into x it will be x square. Now let us find m2. Up to the second section we have RB, the uniformly distributed load 24 and the point load 32. RB is acting in the anti-clockwise direction so that it will be positive and the distance is x. The uniformly distributed load is acting in the clockwise direction so that it will be negative. We know that with this load we have to multiply the distance and the distance by 2. The point load 32 is also acting in the clockwise direction, so it is also negative. For this load we have to take this distance. This distance is x minus 3. We can multiply minus 32 with x minus 3. We will get this. We know that when we partially differentiate the strain energy with respect to Rb, it will be 0. In this equation, only we have to partially differentiate m1 square and m2 square because 1 upon 2 EI is constant. When we partially differentiate m1 square, we will get this, and when we partially differentiate m2 square, we will get this. We can eliminate all of the 2's. Then we can take 1 upon EI on the other side. 0 into EI, it will be 0. Now let us partially differentiate m1 with respect to Rb. For Rb, it will be 1. In this term, there is no Rb, so it will be 0. 1 into x, it will be x. Now let us partially differentiate m2 with respect to Rb. For Rb, it will be 1. In these three terms, there is no Rb, so it will be 0. 1 into x, it will be x. We can multiply this with the x, we will get this. And we can multiply this term with the x, we will get this. Now using this formula, we can do the integrations. After integrating and simplifying, we will get Rb. For Rb, we will get 64. Now let us apply the rule sigma v is equal to 0 and find RA and RB are acting upwards, so both of them are positive. The point load and the UDL are acting downwards, so both of them are negative. With the uniformly distributed load, we have to multiply the distance 6. Finally, for RA, we will get 112 kilonewton. Now from the point B and about the point A, let us take a moment and find MA. RB is acting in the anticlockwise direction, so that it will be positive and the distance is 6. The uniformly distributed load is acting in the clockwise direction, so that it will be negative. We know that with the UDL we have to multiply the distance and then the distance by 2. The point load is also acting in the clockwise direction, so it is also negative and the distance is 3. Let us assume that MA is acting in the anticlockwise direction, so that it will be positive. Finally, for MA, we will get a positive value. That means our assumption is correct. MA is acting in the anticlockwise direction. Now, using the right hand side rule, we can find the shear force values. Here you can see the shear force diagram. In this point, the shear force becomes 0. In this point, there will be maximum positive bending moment. In the beam, in this point, let us make a section and find the distance. You can see that I have made a section at a distance of x from the point B. We know that in this section the shear force is 0. Using that concept, we can find the x. From the point B, we can find the shear force. In this case, we have to follow left hand side rule. Upwards will be negative and downwards will be positive. RB is acting upwards, so that it will be negative. The uniformly distributed load acts downwards, so it will be positive and the distance is x. Finally, for x, we will get 2.667 meter. Now let us find the maximum positive bending moment. RB is acting in the anticlockwise direction, so that it will be positive and the distance is 2.667. The uniformly distributed load is acting in the clockwise direction, so that it will be negative. With the UDL, we have to multiply the distance and then the distance by 2. Finally, we will get 85.33. Now let us find the bending moment in the point C. Here the distance is 3, so only we have to change the distance as 3. We will get 84. Now let us find the bending moment in the point A. Here we can use right hand side rule. In the point A, we have MA, which is acting in the anticlockwise direction, so that it will be negative. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. This is the point of contraflexure. Let us make a section in this point and find the distance. You can see that I have made a section at a distance of x from the point A. Let us use right hand side rule and find the moment. We know that it is 0. MA is acting in the anticlockwise direction, so that it will be negative. RA is acting in the clockwise direction, so that it will be positive and the distance is x. The uniformly distributed load is acting in the anticlockwise direction, so that it will be negative. With the UDL, we have to multiply the distance and then the distance by 2. Then we will get this equation. Using the calculator, we can solve this equation. We will get two answers. 7.93 is not applicable, so the value of x is 1.54. Let us apply that. Now we are going to end this session. Thank you for watching this video.